Welcome everybody to today's Android Brown Bag. Today is, I think, July is today. It's the 26th. And we've got Brian Cooley here today to teach us about RoomDB. Brian is an Android engineer who has worked at GoPro, at FetchMD, a couple other spots as well. And we're excited to have him to teach us a little bit about Room. And also, it sounds like he's going to give us a little intro on Kotlin coroutines, which I know is something that some of these students have had some exposure to, but any additional exposure is always great. So excited about that. I'll hand it over to you, Brian, to kick things off.
Okay, great. Thanks. I'm just going to hop into the presentation over here and just appreciate everybody attending and giving me a chance to talk a little bit about Ring database. I have a URL, tiny URL at the bottom here. Cooley, that's me, and LS for Lambda School. So if you want to get the slides afterward, you can always jump over there, and you should have view access to that. So just a little bit about me. Like a lot of Lambda school students, I had another career before I was a developer. I was a chemical engineer for about 15 years and never had any formal computer science training. Just taught myself how to code and started doing freelance work in 2010. Made the jump to full time and started a company in 2011. When I'm not doing mobile development, I'm usually taking classes to learn more about data science and machine learning. And, I really enjoy learning new things, and I really like to share what I know. So, feel free to reach out. Glad to answer any questions or learn something new from you. You can hit me up on Twitter at BLCooley, or my GitHub is BLCooley, and you can see my LinkedIn there if you want to connect on LinkedIn. So basically, we all kind of know why we're here to talk about Room database. And the problem starts when you want to save some data on Android. You need to find a good place to save it, and your options are limited. You can use shared preference, which is just a key value store, but it's got a limited size, and it's not really the most efficient way for retrieving data. And then you have flat file options either on internal or external storage. But really, if you need to use a database for any kind of complex relational data, and you don't have a lot of options, what ships sort of off the shelf or in the shrink wrap of Android is a SQLite database, and so that's how most of us start looking at sort of the platform specific. The old way, the prior to 2017 way of dealing with the SQLite database on Android, just to use basically SQLite OpenHelper, and which is just a low-level API, and you can use it for your all of the different things you need to do, like create, update, migrate, delete databases. And basically you do that by creating strings. So here I just have a string constant, SQL create entries. And when I create the database in my helper class, I'm just going to execute that SQL statement, and it's going to run and hopefully create the database. And when I query, I have a similar option. I have a query option, and I just pass it some strings for the table, a column I want, some kind of selection options and some kind of sort options. So let's talk about that a little bit. So some good and some bad. Not a whole lot of good, unfortunately. I mean, I don't know what other option you really have to access the database, but it's nice because you can write basically. You have the power of raw SQL for what that's worth. Is that power or not? I don't know, but you have it. And what's bad is that it generally requires a lot of effort to use, and there's no compile time verification of the statements that you write. So basically, if you make a mistake in your SQL statement, you make a typo or something like that, you're going to find that out when you run it, which hopefully you've tested everything, so you catch that. But if you didn't, even if you do catch it, you're probably running lots of tests or running it manually, and that's taking up a lot of your precious and valuable developer time. So you want to try to avoid that. And then when you get what you get back, if we look back, we're getting a cursor back, which allows us to go move forward and back, reset, et cetera, the data set, and look through the rows that are in the return data. But if we really want to do anything with that cursor, you've got to convert that into your POJOs, your model objects, in your app. And so that's going to take a lot of pretty tedious code to convert this cursor data, to figure out what's in each column, what the order is, et cetera, and convert that into the appropriate fields of your model objects. And then, nothing stays the same, right? You're always going to want to evolve your schema as your app evolves, as you get new requirements or you remove functionality. You're going to change the schema, and when you do that, the only option you have with SQLite Open Helper and these string queries is you've got to go through your database, and you've got to you got to go through your app codes, and you have to check your queries and make sure that you've renamed that field or added the new field in all the right places, and that's also tedious and very error prone. So, and just for the final word, if you go to the SQLite page about saving in SQLite on the Android developer in the reference documentation, what you'll see is this big caution that says, you've got some power, but we highly recommend using the room persistence library. So even better, like get on some room. So let's talk about that. So what are the good things about, or what is room? It's a persistence library that's part of the Android Jetpack, specifically part of the architecture components. Okay. And so it takes care of all the chores of setting up and configuring your database. You don't have to write all of the table create statements and configuration you can handle through Kotlin or Java code. And similar to the database Open Helper, it sits on top of SQLite. It's using the off-the-shelf database, and probably the biggest thing. I'm not going to read all these points, but two biggest things: you have compile time validation against the schema, so you shouldn't have any runtime failures. It shouldn't even build if you have typos in your SQL statements, or if you change your schema, you should get errors throughout your code wherever this particular field is used. But probably one of the biggest things, and really the reason that I would say you're really not doing yourself any favor if you're trying to use architecture components, is that Room can return data from the database in the form of live data objects. So let's just talk about that for just a second. So this is the recommended app architecture that Google has put forth. You may be familiar. For many years, Google didn't give any kind of architecture guidelines about how to build, what was the right way to build an Android app. They just said, we give you these tools, and you build it the way that you see fit. But I think over the years they kind of saw that there was some value in really kind of helping folks along to build apps in a way that was performant, less error prone, and just followed solid software development principles. So they released the architecture components. Part of that is this diagram, which basically is telling you, so so your activity or fragment, this is basically if you may have heard of MVVM architecture, model, view model, um, uh, uh, and so basically, like what we're doing here is in the view, this top little activity fragment is the view, and it's going to handle just UI information. It's not going to make any sort of business model decisions. It's going to just handle like how to get stuff on the screen and update it. And then that gets its information from the view model, which contains these live data elements. Okay, so basically, if you can go down to your database level, so just to finish up, you have a repository which handles, if you have some kind of backend component, you can get that using some kind of API like Retrofit. But then you may also want to do some storage on the device so you can use it offline or cache, or just keep track of user input, many cases for it. And it's really nice if this database layer, this room library, can return exactly what you need in your view model. Okay, and so the idea behind live data is that live data, if live data works like in a reactive way, so that as the live data changes, the view gets informed, and you don't have to like wire everything up and write your own updates. You just say, hey, I want to observe this piece of data, and when the data changes, I want to do something. And we'll look at that in a little bit in code, so it'll be a little bit more clear. All right, so basically, the room library defines a few components, and the big thing is the database. That's the object that provides you with your access via. One thing it uses is a DAO. DAO stands for Data Access Objects. And this defines all of the methods you're going to use to access the data. And the data is defined in some entity classes. And basically, the entity classes map to tables in the database. Okay, so let's kind of dig a little bit deeper, and we'll look at each component. So the big component is the room database. It's an abstract class. Room database is an abstract class. This is written wrong, but the database is a class that you write that extends the room database, which is in this package. Okay, and so here's a statement down here. Here's your abstract class that is extending this room database, and we're providing it as part of the database annotation. We're providing it with our model objects. So we have user class, book class, loan class that are going to define the fields that are the columns in our database tables. Okay, and then we have some version number that's associated with it so that we can do migrations later. Okay. The second component is the DAO, and this is kind of where the action is happening. And basically, you're defining in the DAO. You define different kind of queries you want to do. You do that with raw SQL. Some things that you want to do, you don't have to write the SQL for, like inserting or deleting. And one of the nice things is that you can define, and this is good practice, to define multiple DAO objects, for the same room database, so that you can, everything is, properly encapsulated, and you have separation of concerns. A lot of times with the old style SQL Open helper, you end up with classes that just are monolithic and have tons and tons of methods for basically every operation you want to do on the database. So this helps keep the code a little bit more manageable. So an entities are objects that are annotated with an entity, and like I said before, they represent tables in the database, and each of the member variables are columns in the table. So for example, this class loan, it has a string ID that's going to map to some kind of text field, string field in the database, and then it has a date, start time. We'll talk a little bit about that. There's not really a date time most of the time. Actually, I don't really know how SQLite stores dates except for long. So you have this date converter class that you pass to it that does the conversion. So all of this small class, with a handful of member variables, that basically sets up the entire table in the room database. And then one sort of interesting thing, you can annotate columns as which is your primary key. You can annotate with certain information about the column, one of which is the name. So you can have a name in your database that's like, this one is book underscore ID, which happens to be different from your member variable book ID, and Room handles the conversion, picks out the right class from the database, and passes it into the proper member variable when it's converting it into the Java or Kotlin object. So this is kind of what I was talking about. You have several different annotations that I think we saw all of these in the last slide. You have actually, I think these are actually DAO. Sorry, these are DAO, query insert delete or DAO. But these first three, primary key, column info, foreign key, are some of the common entity annotations. Okay, but so we kind of talked about these type converter classes, and here's a view of the transformations. This is sort of to help Room out. Room knows how to, Room will inspect the type of a variable, like, for example, the string ID, and it'll know how to convert that into the SQLite database, or if it's an integer, something like that. Some types it may not know how to convert, or you may want to do the conversion in a specific way. Like, I don't know, maybe you have an integer, but in a database you want to save it as a string or something like that, or vice versa. Maybe it's an integer in the database and you want to, bring it back as a string and do something else with it. You can do that in a type converter, and you just pass that to the entity and the DAO classes via this. So this defines these in this class. This defines these methods here, these static methods that return date and long. Defines them as type converters, and then when you go back to sorry, I got a little stuff here. Yeah, so you go to your entity class, you annotate it with the converter so it knows how to convert the state, and then we don't have that in here in the DAO, but you'd also add it there so that it can do the conversion and queries if it needs to. Right? And kind of the final thing I want to talk about is migrations. So basically, over time, your schema is you're going to have new business requirements. Your schema is going to change, and you may want to do some migrations. For example, you may want to add a table to your database. You may want to add a column, delete a column, something like that. And so you do that in these migrations, and you basically define the migration by the version that you're starting at and the version that you want to go to. So this migration, this is actually an abstract class migration. And so we're just defining an anonymous, this is Kotlin, we're defining an anonymous object that is a migration from version 1 to version 2. And then it just contains the SQL that we need to add or remove, or add tables, remove, add drop a table, add a column, whatever we need to do. We write that in SQL, and then we in the database builder we'll call add migrations with whichever migrations we want to perform. So this migration would enable you to go from version 1 to 2, and then version 2 to 3, and update whatever database based on the version number that's stored on the user's device. All right. So I'm going to switch to some code now. Appreciate your patience going through a bunch of slides and text, but I just want to look at a couple things in code, and I just borrowed a couple of code labs that Google has. One is actually, like Justin said, it's a Kotlin coroutines, but it has a room database in it, and it's a very simple room database. So I kind of want to talk about that real quick because it fits almost on one screen. So I'm going to switch over to Android Studio here and just take a look at it. So unlike Java, you can define a bunch of top-level classes in the same Kotlin file. This is Kotlin, and so we've got our 3 entities. We've got our database class here. Very simple class. We're passing it the title entity. This is version 1, and we're not exporting the schema. And we're going to return. So the database will always return the DAO via an abstract object. So that's what we're doing here. We're defining this DAO in the class so that when the room database builder builds it, we'll have this DAO. The DAO is defined here with just a couple of methods. There's an insert method, which is creating a title, and a load method, which we have the SQL here. So for this, this is kind of not a typical, like this would be maybe like a find by ID method, but you normally wouldn't specify the ID like this. We'll see that in the other project. But and then finally, the entity we define, it's just a simple entity with a primary key of ID, and it has a single value string. And so again, Room will convert this title to text in the database, and yeah. So it's not really a lot interesting in how this works. It does. There are coroutines in this. I can find them. Oh, it's faked out. Yeah. All right. I'm not going to spend any more time on this, unfortunately. I haven't looked at the coroutine part of this closely enough to be able to teach on it, unfortunately. But I will switch over to the other code lab. So this code lab is this is actually a Room persistence code lab, and so we'll just look at the data model first. So this is kind of what we talked about earlier. We have a user entity class, uh, a loan entity class, which is a little more complicated. It pulls in some foreign keys from the book and the user. And the idea behind this foreign key is that um, it knows to match these elements up, this book ID, user ID up with the values from the other table based on what's returned from the database query. So it's putting this, this all together, and it knows that this book ID refers to an actual book object from the database, and that the user ID refers to a user object. Okay, so all right. So one of the first things I want to look at is in the DAOs, right? So one of the things we talked about earlier was that that room parses the SQL in a query statement. So if you make a typo, for example, you'll immediately get an error, right? It's telling you, it's expecting some kind of SQL statement here, but what I actually got was something I don't recognize. I got SELET. And so if you try to build this, you'll get an error at this point, and which is, obviously it's compile time error. It's very, advantageous. We don't have to run this, try to test it, or anything like that. We just get it immediately. And then the second thing I want to show along those lines is, so we're looking here in this book DAO, we're looking at the book class, and we're looking at a parameter called ID. Okay, so if we jump over to book, let's say that we didn't like ID as the name of that field. We wanted to change it, and we're not, we're leaving it this way. It's not converted to anything else. It's just changed the name, right? So if I were doing that with a SQLite Open Helper, I would have to go everywhere to every query that contains ID, and in my project, and I would have to update that. But you can see here that everywhere that I had book ID in these queries, it's showing me an error, right? So now when I make updates to my schema and change information about them that's no longer consistent with the queries that I've written, then I have to go back, and then I'll have some information about, where are the places in the code that I need to make the updates. Now, I haven't tried this actually, but I'm wondering if we do a refactor on it. We'll see what happens. All right. All right, so now if we go back over to the book DAO, you can see that everywhere I had ID, I've actually been able to use the Android Studio tools to update that field name and avoid all of those errors. So I don't even have to manually go back and change everything. I just did it using Shift F6 keystroke, which is just standard Android Studio rename, refactor rename. Right. So back to the way it was. Okay. All right. Anybody have any questions about anything so far? Sorry, I've gone through the whole thing without asking for questions.
No, this is really great. I jotted a few down. I'm sure we'll probably stack a few up at the end, but yeah, I'm just letting you run through the magic. This is great. I love that refactor, because I'm sure you've spent a lot of time too, just like having to manually go through and rename stuff like that. It's really nice just being able to do it all with a quick Shift F6.
Yeah, absolutely. And the thing is, like, when you do it's just like when you copy paste or whatever, like you're always going to it's like you always make a mistake somewhere, no matter
Yeah, yeah.
no matter how careful you are when you're doing it manually like that. So it's nice to be able to rely on the tools for
So
sure.
just job security for us, though, right? If it just takes twice as long, I would almost prefer the copy paste as an
Sure,
hourly employee. Yeah, yeah. But yeah, it's slick. It's really nice. In fact, I didn't even know that you could do that, that it would update all of your like query parameters automatically. That's pretty slick. So
Cool. All right. So one thing, like I'll just show a quick example of how to write queries. So this is an example from the code lab. It's basically step one. And so if I run step one of this app, and you can see here in this code on the user's activity, what I'm trying to do is I want to fetch the data, and my variable name is trying to give me some idea. I really want users that are younger than 35. And so when we run this app, I'll put my emulator up. Emulators are so much faster these days, but they're never fast enough, are they? All right, so obviously there's some mistake here that we have Jason Seaver, who is 40. We were trying to get users younger than 35. So basically to fix this up, if we go look at this method call in the code base, we can look at it. We can inspect this query, and we can see that really this is doing nothing, right? It's just saying get the users where their age is equal to their age. Well, that's going to give you every user. So we can simply rewrite it, and I've rewritten it here. We just want to rewrite the query and change this to a less than sign. Then we can go back into our user activity and just update that, use solution. So now we have the other query running, and so depending on how you feel about SQL, that can be sort of a good thing or a bad thing. Like you still have to know SQL enough to be able to write these queries. Okay, so now we see that JSON is gone, and we've used the correct SQL query in this case. And yeah, just to note, like as they say, this is in the activity. This really is logic that it doesn't really belong in the activity, but they've kind of taken a shortcut by having a member variable in the activity for the database. So that's why they're doing this code here. But normally this would belong into this kind of stuff would probably belong in your view model and not in your activity. So user DAO. Okay. Let's see. Let's see what else interesting we have about this. Probably. Pardon me while I just look. Okay, yeah. So this is really just showing how the type conversion works, right? So we're calling this function. We want to find books based on a date, right? Like we want to see this person has borrowed some books, but we want to filter that on the date, right? So we go look at this query. So here's the query here. We're just selecting from this books table and doing these joins. And then we want to use this loan time after, right? So you can see that, like we talked about during the slides, for this book DAO, we passed in the state converter class. which we can go look at. And this is really just the code that we showed in the lecture. This is code that's converting, a date. It's converting a long into a date using just this, constructing a new date based, passing it to long, which is a standard date constructor in Java. And then vice versa, we can convert a long. We can convert a date to a long to pass into the database. So that's what's happening here in this. What we're doing here is we're just generating a calendar, and we're getting the date from yesterday and passing that date into the into the query. And the query is expecting a long, so all of this is handled automatically by Room, just by using the date converter class that we talked about. And then there's one more thing. The final thing I want to talk about is this guy, loan with user and book. So I'm going to look and find where this is used in the code. And so sometimes like you might want to do something with the data that's returned, right? So you get this live data back, right? Like if I go to find loans by name after, right, that we were looking at, right? So this returns a live data, and we want to do some kind of operation on it, and so what we can do is when we get this information back, these loans back, we can actually pass them through a map function. Okay, so a map function is it takes in one collection, performs an operation on everything in the collection, and then returns a new collection. Okay, and the interesting thing about this is that we're taking in a live data object, not just a list. Okay, we're taking in, or array list or something like that. This is actually a live data that contains a list inside of it. So you can see the signature here, right? But when we map over this, and this is just converting, it's doing the simple date format, and it's returning a string basically, so what's happened here is, like, we've taken this live data object, we've taken the elements that are inside of it, which are these objects with the different fields on them: book title, username, start time, end time, and we've done this mapping, and then we're returning this string for each one of these objects. So we started out with a live data of a list of loan with user and book, and what we got back is this object, which I'm just going to hop over to it so we can see its signature. But it's a live data string. Okay, so we've converted this list of objects into a string, kind of like underneath the live data container, and we're still getting a live data back. So that's kind of an important thing, and you'll get a lot of use out of this. This is part of this transformations class, is part of the architecture life cycle component. So you can use this to take live data, manipulate it, get live data back without having to do a bunch of sort of that tedious machinery of moving pieces of information into other data structures to get them to match up with your architecture components. So yeah, I think I'll end it there. This is the links are in the presentation. Please feel free to maybe go check out the code labs and work through them a little bit. They're very instructional, and glad to answer some questions for a little bit. Could be about Room. I'm also about freelancing or jobs or whatever. I'm glad to talk about, whatever is on your minds.
Awesome. Thanks so much, man. This was a really good presentation. I picked up a couple things. I've used the stuff before, and I picked up a few things, so it was nice. And I want to read for you a comment. Somebody wrote a comment that said um, that he has used live data several times before, but used it in a traditional database kind of way. If nothing else gained from that presentation, that right there is gold to me. And then a bunch of great emojis, a 100 emoji, a fire emoji. So looks like folks also enjoyed the talk. So appreciate you putting it together.
Great. Thanks a lot.
Yeah. So have you used other ORMs like outside of Room? Have you used the one that comes up a lot, of course, is Realm. A lot of
Mhm.
folks tend to like Realm. Have you had an opportunity to kind of compare and contrast between like using a Realm versus a Room?
Uh, so I've done a little bit of Realm work on the iOS side, but never have used it in Android. And I would say it's similar. Like it's got that same sort of reactive um, aspect to it, which is, I mean, that's one of the really nice things. But as far as I know, it doesn't it doesn't really play nicely yet with the live data architecture component. So for me, it's kind of like
Right.
almost a non-starter if you want to use architecture components.
It also just feels a little bit too magic for my taste personally. I don't love just having like a black box of like things just magically happen. I just like magically get data back, and I'm not quite
Right.
sure how that happens. I feel like this is a little bit more verbose, and obviously it makes it a bit clearer as well, since you have clearly like explicit, SQL CRUD operations happening, and you can kind of see how that stuff is happening. I also really loved just observation. I love the ability to pass in like calendar.day -1, because date arithmetic, of course, is the scourge of like Java, Kotlin, Android developers everywhere. It's like, seriously, I've spent weeks and weeks on like trying to do basic data arithmetic. So that's like a really slick. Just that little piece of code feels really slick to me, and I think kind of illustrates the impact of something like this. So yeah, that's really cool. Have you had what about like debugging SQLite databases? Do you have any favorite tools? Like say, you perform a migration and maybe the migration doesn't happen the way that you expect or something, and you want to actually be able to go around and like poke through the different tables in the schema. Have you used any tools there that have been helpful, or have you run into that yet?
Yeah, so it's been a little while since I've worked. So I actually like worked in the database like in its raw form, but there's like an open source. It's really just kind of like an executable almost that I downloaded, and it's basically like it just sort of like a spreadsheet view into databases, and I don't even remember. I think it's just like um, SQLite viewer or something like that.
Right.
And like just really like very very basic. And so I used to actually like take the stuff off the emulator, file transfer it to the laptop, and pull it up in that. And kind of painful. That was kind of a painful thing. Like I was actually before this talk kind of googling around to see if there was some way to
Yeah.
look at SQLite inside of Android Studio. But
My favorite tool for that, just a quick plug, my favorite tool for that is Stetho, which is Facebook's like debugging stack. And it lets you use Chrome inspection against an emulator or a real device, just any ADB device. And it allows you to
okay,
actually poke around. It's like kind of crude. It's a similar deal. It's like what you're saying. There are all these like SQLite viewer kind of tools as well. And it's a
yeah,
little crude too, because you have to like use the like Chrome inspect sort of stuff, like the like debug tools in Chrome, but then you can kind of poke around in there. But I wonder if that's happened. And then that leads to the next question, which is, have you ever looked into doing backwards database migrations, like rollback? Say I go to version from 2 to 3, version 3 is like everything's on fire. It's not what I wanted. Like, can I roll back to version 2 easily?
I have never done that. I wonder if you can write like a migration, like the reverse migration 3.2 and
Yeah, yeah, I haven't either, but usually like I'm thinking of like the old Ruby on Rails, they have like that syntax. There's like some syntax for like going backwards for like an oops, I ruined everything. And I imagine there must be something, but I don't know what it is either. I
yeah,
bet one of these students probably knows the answer to that one, but yeah.
probably.
So then do you keep just one other, have you kept like a bunch of would you keep all your migrations, say from 1 to 2, 2 to 3, etc., in like one place, like a migrations folder or something like that, like some place to keep them organized?
Yeah. So like the migrations themselves would, they'd be a file. Um, but the other thing that you can do is, and I didn't talk about this, but if you go to the database, like this app database, so you can do export schema as
Oh,
free.
that's cool. Yeah.
Okay. And so what you should do then is, and I'd have to look it up, but you go into your build.gradle for the app. And so like under your default config, there's some kind of annotation you can put in here, and you put in, it's called room dot, anyway, I don't know. It's the data. It's like the directory, persistence directory or something. I can't remember, but
Right, right,
it's,
right.
it's, it's like the directory where it saves. And then every time you do the migrations, you'll get the schema saved in that directory, and you can add it to source control and all of that stuff, so that you have your schema from the different versions.
Right, right. Yeah, man, that's the other thing is I feel like I spend a lot of time in Google just like trying to remember Gradle syntax for stuff like that.
Yeah,
Like
you
I
have to
can
know a
never
lot of stuff
remember it.
to do with.
Right? Yeah. Yeah, that's pretty slick though. I didn't know that you could actually just like spit out the schemas on disk somewhere. Somebody posted, I don't know if you could see the chat. I'm going to turn it over and just see if hopefully you don't mind, Brian, if we keep you a couple minutes past 1 Pacific. I know we
Oh, no
started
problem.
a couple minutes late, but I'll turn it over to students here to ask better questions that I'm asking. But it looks like Brandon actually posted the schema exports thing. See, these students are good, man. They're on it. But there was one other question. Patrick, who's in, it was asking also. It looks like he has written a method called create database that just does the room.database builder bit. You must have that somewhere in your code. But in his case, he's written this. I guess it's like a. Yeah, there you go. That's the. You're doing in memory database builder. But
Yeah,
this is like a builder pattern, and he's invoking the method fallback to destructive migration,
right.
which, as its name suggests, I guess would like
Right.
overwrite previous versions of
It,
migrations.
it just drops the database and recreates it. If
Oh,
you have any data in your database, you lose it all at the migration.
interesting. Yeah. So he was asking if that was a bad practice. So I guess it depends. Like if you had, patient cardiac data that could not be lost and like absolutely needed to be there, then you wouldn't do that, I guess, right? Would be the
Yeah, I mean, I think you just want to try to save the user data whenever you can, because
right.
that's kind of a bad experience. Like you can imagine, even if it's something like sort of maybe kind of trivial, like maybe it's old text or something like that.
Sure,
Um,
sure.
then you upgrade your app and you go back and everything you had is gone. You'd be kind of like,
Yeah, you'd be
not
annoyed. You'd be annoyed. Yeah, 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 for sure. Just to like provide a very small real world example too to some of the students, we at the last place that I worked, we were keeping track of what we called positive and negative events in the app. So if a user placed an order and then they rated that order 5 stars, we would call that a positive event. If they rated their order 1 star, then we would call that a negative event. And once we had exceeded a certain threshold for positive events, we would pop up that annoying dialogue that's like, hey, it looks like you're really liking our app. Would you like to leave us a Google Play review? We did all this with Room, and just kind of like a couple tiny little CRUD operations. But to my surprise, that little dialogue that we've all seen, it's pretty annoying, but that improved our conversion rate for 5 star reviews it was like crazy. Like the app went from like a 3.8 up to a 4.6 in under a month, which was surprising to me. It's like one of those things that I had built a couple of times, but just being able to do the like room boilerplate to keep track of those like almost in memory analytics, like keeping track of those like positive, negative events was super slick. It just made it really easy. But we did drop that database after some time threshold too, because it was like, who cares? Like this isn't stuff that's like mission critical that we want to keep around forever. So I guess maybe that's another example. Any questions from the students? I know people are kind of jumping into the chat. Couple other places. Looks like there's a little conversation going on in our Slack, which I wish you had access to. But any other questions from anybody else? Cool. All right. Well, apparently it was a perfect presentation. Everybody got exactly the right information. Again, really appreciate you doing it, taking the time. This is awesome. That code will be, I think, really good too. I know a couple folks pinged me and said that they wanted to kind of go check out the code too. So I think that'll be super helpful. And yeah, just really, really appreciate it. Awesome presentation.
Yeah, thanks a lot. I really appreciate the time. And I can just leave with one piece of advice. This is probably my biggest regret. I know that you guys at Atlanta School have a pretty big emphasis on this, but like, just, get your stuff out there. That's probably the thing I've done the worst in my career. And I've still had pretty successful mobile development career, even though I've always been kind of afraid to be seen, but, get the stuff you do out there, do presentations, talk to people, and, it'll help you improve a lot, and
Totally.
and it'll help you be seen as, more of an expert. Yeah, so good stuff. I appreciate
Awesome.
the time, everybody, and good luck going forward.
Yeah, appreciate it. And yeah, we'll chat soon. I'm gonna shut off the recording at this point, but thanks everybody for joining. Thank you, Brian. And we'll chat soon.
Thanks a lot, Justin. Bye.